This video is for entertainment purposes only. The content in this video may not demonstrate proper technique, attention to safety, or compliance with local building codes. Attempting to do the things featured in this video is at your own risk and may result in minor to serious injury and is highly discouraged. Several injuries were in fact sustained in the design and construction of this project. Side effects may include cuts, bruises, headaches, nausea, electric shocks, electrocution, fits of uncontrollable rage, utterance of expletives, and death by unspecified means. So let's take a look at how this works. So we'll start out with this wiring diagram and this nice oversized cursor. So I'm going to walk you through most of this process and basically how I got my particular thing working. I really hope that this inspires some of your own projects. It was a lot of fun to build this thing, for the most part. A little bit of headaches here and there. But I'll show you the types of things that I did, the compromises that I made to some extent, and kind of the stuff that I used to build it all. So starting out from the beginning is the, of course, mainline input, where all the power comes from. So you can get 120 volts AC in there however you like. I chose to actually cannibalize an extension cord. I think that you should think carefully about which extension cord you actually use to do something like this. I preferred to have a ground in mine, though none of the devices that I've plugged into it thus far, including especially the relay board, actually required a ground, but I like having a ground in my stuff if you're going to build it, worth building correctly. I also like this particular extension cord, not only because of its look and it's flat and all that kind of thing, even though I'm obviously going to discard the female end of it, or rather I repurposed it, obviously. The reason why I like this extension cord is because the leads, as you can see, are well delineated. And so what you can do is after you cut the cord, you can actually pull it apart with a pair of pliers here. And so ultimately I ended up plugging this entire apparatus into a nearby power source, which was actually the closet light. So I replaced the overhead closet light, which was just a single standard bulb, I believe it was a CFL. And I replaced it with this outlet right here. So moving on from there, as soon as the power gets into the box, it gets immediately thrown into this breaker switch right here. And so each one of the relays is limited to 10 amps. So I decided to actually have the entire system limited to 10 amps. So, no vacuum cleaners or anything like that plugged into this thing. But I'm okay with that compromise, and not only that, but this the switch, if the more current gets drawn, it just trips the switch and you can just hit the button once again. I think it's a really cool safety measure, and it didn't really take any time to install or throw in there, and it was also cheap. So I'm going to point out all of the hot leads in the system. And so after the hot comes in, kind of follows this, one path that goes is to a toggle switch. And so this is an override for two of the outlets, one on the inside of the closet and one on that satellite outlet, that gray outlet, the metal outlet that's on the outside of the wall. And so I like having this override switch. I'll go into a little bit later, but that's how that's wired in. So obviously when the switch is in open mode, then it will default into the relay. So the relay has control over those two outlets, but otherwise it can be overridden. The hot also travels, of course, through the orange cable to the second box. So immediately once it gets into the second box, it gets dumped into our 120 volts to 5 volt converter, otherwise known as a USB charger. And also the 120, of course, gets dumped into 3 of the relays on the communication port. I have my relays plugged into the NO, which means normally open, which means that when there is no power supplied to the relay, the circuit is broken. So I'm going to move on to the control board. So the control board is a really cool piece of technology. It's this Aptinex Internet of Things relay node. It's both cool and also cheap, which is my preferred modality, as you can probably get by now. It's based on the ESP8266 architecture. It's got 4 LEDs indicating the state of things, and also very accessible GPIO pins, except for the ones obviously that are plugged into the relays. I did not use the default software that was installed on this. I just immediately flashed it with Tasmota without asking any questions. I really doubt that there's anything out there commercially that could hold a candle to Tasmota in terms of usability and that kind of thing, apart from possibly the Shelly products or something like that. This is just Tasmota is just so full featured. There's no way that their home built thing could be as good. But even if it were, I trust Tasmota, and I don't know anything about Aptinex company other than they make this good product, and so I don't need to trust their code. I can just use Tasmota. The board takes a 5-volt input, and you can put anything you want on these relays. So for this relay here, I don't know, we can call that relay 4 if you want. I actually have that outputting 5 volts when the power is supplied to the relay. So basically when the relay is on, according to Tasmota, it will output 5 volts, and that goes to a second relay over here, which I'll talk about more in a bit, and why I did that. The other 3 relays, of course, switch the 120 volts AC, which get piped back through to the outlets. This is a fantastic board. Would highly recommend it if you need a 4 relay or even a 2 or 3 relay Tasmatized switch. It is just fantastic. Very good for Internet of Things type stuff. So let's talk about the switches. And so I have 4 switches here. One for each relay, I guess you could say, but the reality is, of course, if you have Tasmota installed, or probably a lot of different ESP8266 software, obviously, I'm sure ESP Home does the same, you can have any one of these switches do anything that you want, especially if you got into Home Assistant. Goodness, you could have it so the closet button is like a panic button that sets off your alarm and calls the cops and turns all your lights on, and then, orders you a pizza. I mean, you can have any button do anything, or any switch do anything when you have it hooked up to something like this. And so that's really what's really neat about Internet of Things devices, in my opinion. So let's talk first about this really jerry-rigged thing. That was the original fan switch that was in the wall. So the fan switch box had 120 volts AC coming in, and then of course the fan going out, just a single pole switch, which inspired this project because I have a very old house. So that leads to 2 things. 1, no neutral wires, and number 2, very small power boxes, like for switch boxes and things like that. So I actually had to hot glue the relay that operates the fan, that connects the fan and the hot 120 volts AC line. I had to glue that relay right onto the side of that switch. It would not fit a Shelly into the outlet, and the original layout of this 5-volt relay I have actually took in GPIO pins, not enough room even for those, so I cut them off and just basically had a relay switch a relay. It's not an ideal situation. It would have been nice to be able to keep one of these relays for something else, but that is a situation. One thing I could have also done is pipe in 120 volts AC into the 4th relay here and have that go through the wall. However, if you do that, you have to watch local building codes. So in total here, we'll get to the GPIO pins in a minute, but we'll summarize. These are all 3.3 volts, and now I'm running 5 volts in for this relay. So that is what is considered conservatively to be called low voltage. So for low voltage wires, there are some building codes that apply, but it just has to apply to the actual cable and how flammable it is, those types of things. And the likelihood of it burning your house down is so incredibly low. I mean, if you think about it, like how much actual power does it take to set something on fire? And would this thing be able to convert that power and dump it in there? And I think the answer is most certainly no, unless of course one of these lines shorted to 120 or something like that. But short of it is that if there is a short, I'm willing to risk it. This is not a thing, and definitely it is within local building codes in my particular area. So I was not going to run a 120 volts AC line through the wall, and so I ran 5 volts to run this relay. And the rest of these, of course, are GPIO. So all of these switches are actually switching GPIO to ground. So for that, you want to have the pull-up resistor enabled. So for instance, in Tasmota, it'll say switch 1N as opposed to switch 1. You want to do switch 1, if that makes any sense. So keep the pull-up, because N stands for no pull-up. Moving on to the second switch. So this is a double paddle rocker switch. I actually I don't like these very much. They're very stiff. And I think that goes for all of them that I bought from various brands. It's just kind of the nature of the game here. So if you're going to have a double switch, you might be better off rolling your own by taking a blank plate and putting in your own switch, like the one I'll mention in a minute, or something like that. One advantage also to using low voltage is that this switch does not actually have its own switch box. It's basically screwed directly into the wall. I have a long construction screw actually attaching it to a stud, and that is okay for building codes too, because once again 3.3 volts, not 120. So moving on to my favorite switch, of course, which is the Momentary switch. Oh my gosh, this little guy is fantastic. The button feels great. It's technically waterproof, though if I ever need to actually use that feature, then I think I've got bigger problems, considering it's in my closet. One problem with this, though, is that it is 19 millimeters for the mounting hole, so this little distance between there. I did not have metric drill bits. I only use Freedom units for my drill bits, and so unfortunately it was a little bit too wide. But I mean, you can probably barely notice. And it was just a kind of a point of pride that it didn't fit in as snugly. But I do recommend getting metric drill bits if you're going to buy this particular button switch, but this was a fantastic buy. So some other random stuff. So these two things I got off banggood.com. The USB power supply, which is something you should not mess around with in terms of quality. Get a good one, especially if you're going to apply this in kind of a permanent scenario like this is. So I used Velcro to actually mount this little USB charger I got off banggood.com. It was $4.35. It did work with 120 volts AC, but look at this little plug thing. What is that? Oh, that's a European plug. Didn't matter anyway, because I was just going to Dremel it off, but I thought it was kind of funny. Definitely will not fit into a tight scenario if you do not remove it, but if you do, oh gosh, it's nice and compact. It's got its own little shell here. So I actually kept the USB header on it. I forgot why. I think I had big plans for some sort of external USB charger, but no, I'm very happy with this arrangement. It just barely fit within everything, but after I cut off the European plug, I filled the cavity with hot glue after, of course, soldering out my leads for the 120 volts AC input, yeah, it's working great. So, project boxes, goodness, Amazon just totally rips you off on project boxes, in my opinion. So, I went ahead and bought these off banggood.com for a reasonable price. They were $14, but that was for 3 of them. And they're pretty decent sized, as you can probably see in the video. Super happy with these. Love banggood.com. I just wish that the delivery times were a little bit better, but it is literally half a world away, so what can you do? Alright, so now the reason why I went with outlets instead of just wiring my lights in directly, well, at least the main reason. I love these things here. So I had a whole lot of fluorescent bulbs, 4-foot long ones in my house in various places, and so I just got hooked on these. This is a 4-foot long LED fluorescent bulb replacement. It works with T8 and a number of other specifications, if that means anything to you. These things are amazing and a million times better than fluorescents. So what I went ahead and did is you can actually unscrew one or both of the ends of these things and wire in 120 volts AC directly. So I spliced in an extension cord. So I use this in my master bedroom closet, and I actually string a whole bunch of these together. Very easy, very modular, and all that kind of stuff. These things are also super sturdy, especially as compared to fluorescent bulbs. They of course contain no mercury. Fluorescents are the worst. They have horrible light. They blink a lot. They require ballasts. And of course they are a total health and environmental hazard. Did you know you're supposed to dispose of these in like certain ways that no one actually ever does? So it just fills up landfills full of mercury, which is really wonderful. Ballasts are also the devil. In case you don't know what a ballast is, imagine the 7th circle of hell and what they might use for lighting. All of them will require a little box that makes noise. It fails a lot, and in the case of fluorescent bulbs, it's necessary to get the proper voltage to get the thing working. But anyway, they're horrible, and this is way awesome. This replacement comes in double-ended or single-ended varieties. And definitely, if you were going to splice in an extension cord, that's how I'd recommend it. Just it makes it a little bit more stable, as you can kind of imagine if you take a close look at what I did. But I also have a single-ended variety as well, which I would highly advise for an actual fluorescent bulb replacement. One of the big reasons is, actually the biggest reason is because I just tore out my ballasts immediately when I could. Out of those receptacles. So all I had to do was just cut the wires to the ballast and then wire the hot and neutral to a single side, which just saved a heck of a lot of time. And so just a single end is definitely recommended for fluorescent bulb replacement, but double-ended if you're going to do what I did, which is splice in an extension cord. These things are bright as heck, and yeah, could not recommend them enough. Okay, so that's it for the narrated part of this video. If you liked it, please, like and subscribe, I guess, and enjoy this footage of how I put it all together. Thank you a lot for watching.